Hi, we are Proxima, and our solution package addresses geological disasters by modernizing, streamlining, and expediting data collection and processing for first responders to better understand the disaster-struck region and optimize their search and rescue operations.
Our technology relies on robust communication between volunteers, remote relief centers, and the local ground station. However, this isn't always possible with the nearby infrastructure. Therefore, we deploy a series of Starlink nodes to establish internet connectivity within minutes. Starlink offers affordable, reliable, and scalable solutions to any and every disaster situation. Using data gathered by the drones in conjunction with Starlink, we can coordinate evacuation plans and provide real-time information on weather updates and creating safe routes.
Our solution starts off by quickly analyzing the conditions of damaged infrastructure around the affected area. Drones with advanced cameras help scan the top layer of rubble for a highly detailed digital view of the site. These images are relayed back to a ground station where they can be fed into a locally deployed pix-to-pix cGAN system. This conditional neural network analyzes the images for all viable transportation routing options and outputs the most efficient path to reach a location within the analyzed area.
The generated maps also serve as a basis for comparison with pre-disaster mapping and population density heat maps, which can be overlaid onto OpenStreetMap to identify critical regions for casualties. We simultaneously utilize XView2, a cloud-based machine learning system that analyzes satellite imagery and segregates areas by the severity of the damage through the comparison of pre- and post-disaster images. Already tested in Turkey and Syria earthquakes, it reduces the time and work that response teams exert in order to rescue people.
Disasters often means that we can't use traditional economic models to forecast resource demand. Our platform incorporates a locally hosted artificial neural network, ANN, to solve this issue. By analyzing decades worth of post-disaster data and simulating current disasters, we can reliably forecast the demand for certain resources at certain times. This can allow for preemptive understanding of what resources will be needed in the future cases. Leaning on both simulations and historical data, we can continuously allow the ANN to learn and have a much higher accuracy and consistency than humans currently do.
Natural disasters can destroy the very foundations of our society. This imposes a new level of difficulty onto the way we engineers solve our problems. We, at Proxima, harness the capabilities of AI to mitigate the consequences of such events by providing a fast, efficient, and effective platform for first responders. Thank you.